All right, let's look at week 7, day 4. We're writing linear equations. Surprise, surprise. But let me introduce to you a new form that we have not seen before. This form is like slope-intercept form because it is an equation that gives us a line if we were to try to graph it, or if we were to put in numbers for x and y, it will give us solutions that form a line. But instead of it being slope-intercept form, which tells us the slope and the y-intercept, this form is called point-slope form. So I bet you can kind of guess maybe what's different about this, because they both have the word slope, but instead of the word intercept, here we have the word point. So this is helpful whenever we're given the slope and a point that's not the y-intercept. And that happens to us actually quite a bit of the time. You'd actually be surprised how often we know the y-intercept, especially if this were, gasp, a real-world problem. Because in the real world, when we use linear equations, it's often because we have a starting amount and then an amount that goes up or down as we, go through time or whatever. And so we do often know the y-intercept because of that, but not always. Here's how point-slope form works. We still have m, which is the slope. We still have x and y, which will continue to be x and y. But we also have these two other variables, x1 and y1, which should be familiar from us doing that with the slope formula. And in this situation, that x1, y1 is the point that they give us, that we're going to fill in where x1 is and where y1 is, the coordinates from each problem. Now, there are pros and cons to this method, as there are to any method. The pros to this method is that it is actually easier to write an equation in point slope than it is in slope intercept, especially if you're given a point that is not the y-intercept. What you're going to find here is that basically we just write it out and we're done. We don't have to do any solving whatsoever. I think the thing that makes people not like point slope, at least not in Algebra 1 when we introduce it, is two parts to it. One is that it just looks less friendly than slope-intercept form because it has, the x1 and the y1. And, that's a confusing notation, especially at first. So I think it looks less friendly, so students tend to not like it as much. The other thing is that because of how much time we spend graphing from slope-intercept form, it just might feel more familiar, and you're like, I just don't want to have to do something totally different on top of it. So we are going to look at point slope and see how it works. Our steps are going to be, for example, 1, we need to figure out what is the slope. Well, the slope is 3, so m equals 3. The 0.25 is not going to be x and y, it's going to be x1 and y1. And so I guess the other thing is maybe it trips you up after the thing we did last time of it being x1 and y1 instead of just regular x and y. But the whole reason that this is happening is because we want to be able to put in these 3 pieces of information and then not have to do anything else. So here's how that works. We do y minus y1, which is 5. So y minus 5 is on the left. And then we put m, then we open up parentheses, and we put x minus x1, so x minus 2. That is the answer to this equation. Now, you might be thinking, that's cool that it's that quick, but it's uncomfortable that it looks like that. You can actually take point slope and turn it into slope-intercept form with 2 very easy steps, which is distributing the slope and then adding or subtracting this number over to the other side. So even if our end goal was to get slope-intercept form, we could choose to use point slope instead of what we did last time, which was solving for b. So, you've got options now, which is nice. If you are trying to graph from point slope, instead of changing it to slope-intercept form, you actually can. You just have to be able to take out these 2 pieces, the point that they gave us, and and be able to say, okay, in the formula are these negatives, just like in the slope formula. And so since this formula has negatives, the x value for this point is 2 and the y value is 5. Not -2 and -5, regular 2 and regular 5. So that's kind of a lot of information on that. So on number 2, I'll just go through and show you what you need to do without any of the extra talk that just happened. So let's see here. We are going to label the slope as -1/3, x1. Remember, that's just a way of saying the first x. And you might be going like, well, there's 2 x's. Why isn't it x1 and x2? And that's because we're going to leave the regular x as x when we're done with the problem. But it's nice to be able to say x1 to say, hey, this is an x value for this particular equation. I don't know if that makes sense. You'll have to let me know, I guess. So we're going to fill this in. Y minus y1. But wait, you say, y1 is already negative. If we subtract a negative, we get a positive. If you want to write out y minus -2, totally fine with that. The next step you do is a plus situation, and voila, we get y plus 2. If you would rather just write it off the bat as y plus 2, that's fine with me as well. M is -1/3, and x is minus -5. X minus -5 is +5. Another pro to this, actually, that I just thought of is that if our y-intercept is a fraction, then this actually helps us get to an answer faster, because even if the point had fractions, or if just solving for b gave us fractions, we're just plugging in on this. And so we don't actually have to do anything those fractions, even if there are fractions. So yeah, that's pretty cool in my opinion. So that's how we do it. That's how we write in point slope form.